All right, good morning to my calculus students. So we're going to talk about the test prep for test 3 here, and we'll see how far we can get with this. So first couple of questions, L'Hopital's rule. So we have limit x goes to 0, x times 3 to the x divided by 3 to the x minus 1. And then the second one, x plus tangent 2x divided by x minus tangent of 2x. And we'll just get started with working on these. Okay, so we have, there we go, we have limit, here's my pen, limit as x approaches 0 of x 3 to the x divided by 3 to the x minus 1. So the first thing you're going to do with L'Hopital's is you're just going to check to make sure it doesn't fit the indeterminate form. So we plug in the 0, and we have 0 times 1 over 1 minus 1. We end up with 0 over 0. Check. It is now indeterminate form. We can use L'Hopital's rule. So you do want to always check this before you go off into saying use L'Hopital's rule immediately. So I'm always looking for, did you check it? Okay, because when you have multiple instances of this thing, you have to apply L'Hopital's like 2, 3, 4, 81 times, that kind of thing. You want to check to make sure that you're getting an indeterminate form every time you do this. Now that we have it, we can apply L'Hopital's. So we're going to go ahead and take the derivative here. So with the derivative of x times 3 to the x. Now we're not taking the derivative of the function. We're applying L'Hopital's rule, which means we're applying the derivative to the top and the bottom to see where the limits go. Okay. Now the first thing I see here is we have to take a derivative of 3 to the x. So the derivative of 3 to the x, I always remembered this as saying, well, we could write 3 in a very fancy way. That's going to be e to the ln of 3, that's 3, raised to the x power. When the exponent is raised to an exponent, you multiply the two exponents together. So this is going to be e to the ln of 3 x. Taking this derivative is very simple. So that's just going to be e to the ln of 3x times the chain, which is going to be ln of 3. Going back to say e to the natural log of 3x is just going to back to be 3. So we're just going to have 3 to the x times natural log of 3. So just to put that off to the side, remember that's going to be my derivative, because as soon as I'm looking at this, I'm like, oh, there's a product rule. We have to take the derivative of this product. So the derivative of the first is 1 times the second plus the first times the derivative of the second. Oh, it's a lucky thing I did that. 3 to the x times ln 3 divided by derivative of 3 to the x is going to be 3 to the x ln 3. Okay, and then the derivative of 1, of course, is 0. Let's clean this up a little bit. So we end up with 3 to the x plus, let's see, x, 3 to the x times natural log of 3 divided by 3 to the x times natural log of 3. We still have that limit, right, as x goes to 0 here, because that's the whole point with evaluating the limit. Now, what I want to go ahead and do is plug this 0 in to see, like, what did we fix the problem? Do we have to use L'Hopital's again, or is there a different way we could do this? Let's put the 0 in. So we end up with 1 plus, when I plug in the 0 here, the whole thing turns into 0. This whole second term is 0. And then on the bottom, we have 3 to the 0, which is 1 times natural log of 3. This simplifies to 1 divided by natural log 3. And that seems to me like that's a reasonable limit. So that's not an indeterminate form anymore. That's whenever natural log 3 is a number. I'm sure it's delightful, but we're done. Okay, so that's what you have to do for that one. Okay, problem number 2. Okay, let's move on to that one. So this is x plus tangent 2x, limit, again, limit the x goes to 0. So let's go ahead and have a look at that. Limit x goes to 0, we have x plus tangent of 2x divided by x minus tangent of 2x. I do wonder if there's some kind of clever thing we can do with double angle formula for tangent, but yeah, we don't make people memorize that anymore, so I guess you don't have to do that. Let's plug that in. So we plug in 0, we get 0, tangent of 0 is 0, so we get 0 plus 0 divided by 0 minus 0, which simplifies to 0 over 0, and that is indeterminate form. So what we're going to do, we checked it. Now we're going to go ahead and use L'Hopital's. Okay. So again, take the derivative of the top. So we're going to go ahead and do that. X plus tangent 2x divided by the derivative of the bottom. Again, we're not using quotient rule, we're using L'Hopital's rule. Okay, so we're not taking the derivative of the function, we're taking the derivative of the top and the bottom is separately like that. So we go ahead and take the derivative. This is just going to be 1 plus, we have to do derivative of tangent 2x, which is going to be 2, that's the chain, secant squared 2x, and of course that's where the 2 came from, was the chain rule based off of the argument here. And then we're going to say divided by 1 minus 2 secant squared 2x. And then what we're going to do is we're going to go back and plug in 0 and see what happens. Well, the secant of 0 is 1. So we're going to end up with 1 plus 2, 2 times 1. And on the bottom, we're going to have 1 minus 2. So that's looking pretty hopeful. 1 plus 2 is 3. 1 minus 2 is negative 1. So we end up with a negative 3 as our limit. And then I think we're okay with that. Okay. I'm going to go ahead and stop our video here, and we'll do number 2 in the next one. So thank you for coming along, and I wish you the best of luck studying for test 3. Okay, we'll see you in the next video. Thank you.